Today we're going to study the particulate nature of matter, different kinds of substances, how do they become stable, and the different forms in which they can exist. So firstly, what is a pure substance? A pure substance is one that contains only one type of particle and has no impurities within it. For example, an element like hydrogen or oxygen. An element is a substance that contains only one type of atom and it cannot be further broken down by chemical means. Then what is a compound? Where hydrogen and oxygen are elements, H2O is a compound when hydrogen and oxygen, two elements, combine chemically together and they form a compound. Compounds and elements both are pure substances because an element such as hydrogen is just made of one type of particle, that is hydrogen. A compound such as water is made of only one type of particle, that is H2O. But a mixture contains two or more substances that have physically combined and have not chemically reacted with each other. So we cannot call mixtures pure substances. When we talk about an atom or the simplest unit or a simplest particle of an element, it's one that can exist itself in a stable environment, retaining all its properties along the way. And what is a molecule? A molecule consists of two or more atoms that have bonded together. For example, hydrogen can only exist as a molecule as H2, and group 7 elements can only exist as molecules, for example Cl2. So pure substances contain only one type of particle, for example elements and compounds. Impure substances such as mixtures contain different types of particles. They consist of different types of substances that have not chemically reacted with each other. Then let's have a look at the main differences between elements, compounds and mixtures. So elements have their own set of properties, compounds also have their own set of properties, whereas mixtures do not have a set of properties, a definite set of properties. They retain the properties of the different substances between them. For example, when you have an element hydrogen, it has its own set of properties. When you have a compound such as water, it has its own properties, its separate properties. When hydrogen and oxygen react, they lose their own properties and a new set of properties is given to them that are the properties for water. However, in mixtures, for example, if you have a mixture of sand and water, so sand will retain its own properties even when it's put into water, and water will obviously retain its own properties. Then, as we discussed, elements can be separated by chemical and physical methods. Compounds can only be separated by chemical methods, whereas mixtures, since they haven't chemically combined, they can be separated by physical methods only. You can have a look at the examples of elements, compounds and mixtures. Examples of elements are chlorine, sodium, copper, etc. For compounds, you have zinc chloride, H2O, water, HCl, hydrogen chloride. And for mixtures, you have examples of salt and sand, chalk and water, potassium chloride solution, etc. Then let's come to mixtures and compounds. So we discussed their separation, their properties. But when we have compounds formed, you have a chemical reaction taking place in which you have an energy change. You have chemical changes. However, when you form mixtures, no chemical change takes place. For example, when you mix sand and sugar, you find no chemical change taking place, no energy change. The container doesn't get hotter or colder, etc. Then compounds have fixed melting and boiling points. For example, water has a boiling point of 100 degrees Celsius, whereas mixtures can have different boiling points. Each substance can boil or melt at its own temperatures. Then compounds have fixed compositions, which is why they're pure, whereas mixtures do not have fixed compositions. In addition, compounds and elements have separate formulas, unique formula. For example, an element like hydrogen has the formula H2, a compound like water has the formula H2O, whereas mixtures such as sand and water do not have a specific formula. Now let's come to chemical bonds. You have two types of chemical bonds, ionic bonds and covalent bonds. We're also going to discuss metallic bonds further on, but the main question is, why do atoms bond? Why do they need to bond? That is something that I discussed at the very start of my video. They have to become stable. Stable compounds have an electronic configuration similar to that of inert gases such as helium, and all the shells of the atom are full with the maximum number of electrons it can hold. For example, 2, 8, 8. Coming to ionic bonding and covalent bonding, an ionic bond is formed between a metal and a non-metal when a metal transfers its electrons to the non-metal and ions are formed due to a difference in the number of electrons and protons. However, in a covalent bond, two non-metals share their electrons, and so that's why that term is that this sharing of electrons is known as covalent bonding. In ionic bonding, the bonds that are formed, they are weaker than covalent bonds. However, ionic compounds have higher melting and boiling points as compared to covalent compounds, and we're going to discuss that in detail further on. So what is an ionic bond? It's a strong electrostatic attraction between anions and cations or oppositely charged ions. Now, what forces binding ions together in ionic bonding? There is a strong electrostatic force of attraction as you have oppositely charged ions held in an ionic lattice, a very strong ionic structure in which the particles are held together by electrostatic forces. When you have a positive ion and a negative ion, they're going to attract because opposite charges attract, and so you have a very strong force between them. What are cations and anions? I've been using this term, but what does it mean? Cations are positively charged ions that have lost electrons, so they have more protons than electrons, resulting in a positive charge. They're called cations. And anions are the complete opposite. They gain electrons, hence they have more electrons than protons, which means they have a negative charge. What is the structure of an ionic compound? It's called an ionic lattice, in which you have positive and negative ions alternatively held together, which is why they are so very strongly bonded to each other. Now, what are the physical properties of ionic compounds? We'll have a look at all of these properties and we'll try to understand why are they so. So when I say that they have high melting and high boiling points, this is because of the strong electrostatic forces between them, and you need a lot of energy to melt these ionic bonds, to melt these ionic compounds, or to cause them to boil, because you want to overcome the forces of attraction between the positive and negative ions, and you need high temperatures for that. They are mostly solid. Why? The molecules are tightly packed together in an ionic lattice, so they are solids and they have a high density resultingly. They are hard and brittle. Why? Ionic crystals are hard because the positive and negative ions are strongly attached to each other and they're difficult to separate. However, when pressure is applied to an ionic crystal, then ions of like charge may be forced closer to each other. The electrostatic repulsion can be enough to split the crystal, which is why ionic solids are also brittle. Let's have a look at it with the help of the image. So you have an ionic lattice at the very left. You have positive and negative ions, anions and cations that are held together by electrostatic forces of attraction. When you apply a force on it, an external force on this ionic lattice, the like charges come together, and as we know that like charges repel, these particles move away from each other and you have crystal cracks formed as shown on the right side. So that's why they're brittle, which means that they can easily shatter when an external force is applied on them. Then they're also good insulators. Why? Well, conductivity is the flow of ions or electrons. Since in a lattice you don't have, the ions are held so tightly together in a lattice, they cannot move, you cannot have a flow of ions, and since there are no free electrons, you cannot have a flow of electrons either. So they're good insulators. However, when you have ionic compounds in molten form, for example, you have molten sodium chloride, or you have them dissolved in water, for example, you have aqueous sodium chloride, then they conduct electricity. Why? Well, when they're in a molten form, so the ions separate, the strong forces of attraction between them are overcome, so the ions are free to flow and you can have electrical conductance. And in water, the ions dissociate. The H plus positive ions in water pull the negative ions or the anions in the ionic compound, and the OH minus ions in water, they pull or they attract the cations or the positive ions in the compound, and so the ions dissociate and they separate. So the ionic compounds can conduct electricity when they are molten or dissolved in water. Anionic compounds are soluble in water, again because H plus and OH minus ions pull them towards them. The ions dissociate, so they also dissolve in water. Let's see why they can conduct electricity in molten or aqueous form, because the ions are free to move, so they can now conduct electricity. However, in solid form, they're fixed in lattice, so the ions are tightly packed together and they have no space to move, so you have no electrical conductance. What is lattice energy? So lattice is the structure of ionic compounds, and lattice energy is the energy required to melt these strong forces of attraction in the lattice, is the energy required to melt the ionic lattice. What are covalent bonds? We're done with ionic bonds now.